Well, hello guys. Welcome to the second video for IFR Made Easy series. And today's topic of discussion will be navigational arcs. So most of you, you must have heard about DMA arcs. It's the wrong word to be used. It should be referred to as navigation arcs. So these are like the definitions, as you can see in front of you. These are definitions and the purpose of a navigation arc, which you can find on internet, but still I have noted down just for like introduction, who does not know about it. So by definition, navigational arcs are curved paths that are flown by aircraft at a constant distance from the navigational aid, such as a VOR or a GPS, from thereby getting the name, because DME, distance measuring equipment, is usually used in conjunction with a VOR, and with the GPS, you get a distance automatically via the satellite. And if the aircraft keeps flying the arc, the flight path shall result in a circle around that aid at a fixed radius. Now, I would like to explain you this with the help of an IFR chart. Most of you, I hope, have a IFR chart with you handy. And I would just upload, I'm sorry, I would just upload a IFR chart that I have already, just a second. And just a second. Let me expand it so it's visible to everyone. Yep, it is. So what do I mean by a curved path? So two basic requirements of any navigational arc. As the word itself says, first, it is in a need of a, what do you say, a navigational aid. So I've taken this IFR cross-section chart because that is where I was trained, and it's easier for me to spot the places where I used to perform DME arcs, thereby making it easier for me. The same method can be applied to any place. So if you look over here, let's take an example of Orlando Executive VOR. So if you can see, I'm marking it with a red. This is the Orlando Executive VOR. The frequency can be seen. The it can be denoted with ORL, Oscar, Romeo, Lima, and here is the Morse code. So if this is the navigational aid. Now, what I mean by a constant radius, now let's just draw a 20, okay. Now, I know the line is not straight, but let's consider this as a straight line. You know what? Let's make it perfect. Let me remove the annotations and let's make it a 20. Now, I know a point which is already at 20 DME because we used to perform those DME arcs. As you can see, this thing, just a second, this point, its name is Mambo. I know it is 20 DME from the Orlando Executive VOR. So what we can do is, let's just take and join this point. Yeah. All right, that looks good, much better. So just for let us say this is the radius. I know this is 20 DME. How do I know that? one is the experience, and second, if you guys already know how to read a IFR, low IFR chart, the distance is written right over here. So you see this 20. So this 20 means basically from Orlando Executive up to this point called Mambo, which is actually a GPS fix as well. But let's just, for the sake, say it's a VOR point, and it is at 20 DME. So now, if we draw a circle, I know it's going to be rough, but let's just say, all right. So let's just say this is a navigational circle that we have drawn around it. If we take, this is a, like, let's just say we take this cross section, all right? So if we fly this part, just this part, why would we do that? I'll come to that later. But if we fly this part, this will be called as a 20 DME arc at Orlando Executive, right? So that's pretty much how like an arc is. But yeah, so that's pretty much it. Now, why do we fly it, right? Now the question like arises like, why should we fly it? To reduce workload on approach controller. So it basically, what it does is, suppose an aircraft is arriving from here. Now you can see these are all kind of airspaces around here. We have Sanford International, this is a class Charlie. Over here we have a class Bravo, and let's just say there's a lot of traffic which is flying around here, all right? And the approach controller basically wants you to fly via this route. He wants you to fly all the way to the right and follow this this Victor for 159 and inwards. So you can read here, it's written to reduce workload approach controller area to streamline air traffic. And hence, in that case, what happens? All the aircraft can be directly asked, like, let's just say your call sign is iFly061. They can directly ask you iFly061, turn right, and join a 20 DME arc to Mambo and track Victor 159 on radial 159er to Orlando Vortac, right? So what it does is, now he doesn't have to like constantly give you vectors all around that turn left, turn right, because let's remember, you're not the only aircraft in the air. So it helps streamline the workload. So this is one of the reasons, right? Sorry for that. Just a second. Yeah. So second, to enter an approach pattern. So what do we can read the third and the fourth point in conjunction: to enter approach pattern or to execute a published approach. I'm sorry for my spellings over here. Yeah, there you go. To execute a published approach. Now, what do I mean by that? Now, there are certain airports in the world which ask you to intercept a localizer, but before that, you have to track a 20 mile, 10 mile, 7 mile DME, right? I'll give you an example for that. The recent example I know, I think, is Daytona. In our area, it used to be Daytona. Just a second. So what we can do is we can go KDAB. I think it was ILS 07 approach. Yes, there you go. Yep, there it is. So if you see this uh, chart over here, you can see it is asking you to follow a 18.9 DME arc from Ormond. I know Oscar Mike November. Oscar Mike November basically stands for Ormond. You can see it right here. So Ormond Beach, you have the frequency, the call sign, and it wants you to fly. If your initial approach fix is Samira, you can fly a 18.9 DME arc directly to join the localizer for runway 07 and intercept the localizer at Warmal, right? Now, if you're inbound from Hanav, which is north, and you're flying from there, you can join a 16 DME to Ormond Beach and join the localizer at Tiger. So this is what basically it means in order to like uh, follow a approach procedure. And there are many more examples to it as well. Whatever I'm saying, it happens same. I know I'm just giving the examples of the VORs. The same principle applies for GPS fixes as well. You pick up any point, uh, but VORs are more like mostly used till date on all our approach charts. And the last point, why we do it, to enter, exit a holding pattern. Now, I just want to, if you could just give me a minute, I would like to delete this, right? And the same thing. Now, let's suppose, again, I'll be drawing this, just a second, guys. Sorry. Yep. So let's just suppose we took off from here, right? And like, suppose I took off from my airport, right? I took off north. Uh, let's just ignore this for now. Yeah. Okay. Now, suppose I want to fly to Orlando Executive, which is this place. But as of now, there are a lot of aircrafts around in this area, and he wants us to be established in a hold at Mambo, right? So what he can ask that, let's say my call sign used to be LFA and whatever number, that used to be the letters, and we used to be called Bucky. So let's just say Bucky 310, turn left, fly 360, intercept a 20 DME arc, all right, and establish yourself on a hold, establish yourself on a publish hold at Mambo, right? Makes sense. So what I have to do is now, I know he has given me the command. He doesn't have to interfere with me. He doesn't have to keep vectoring me. So what I can do, I can go straight, intercept the, just a second, I'll just show you. I can straight away intercept the 20 DME at over here and join it all the way down to Mambo, thereby avoiding all the traffic over here, and establish myself in a published hold at Mambo, right? Now, how to join a hold and what kind of hold it is supposed to be, I'll do it in a later part. But for now, uh, let's keep it simple. That's how you join a hold via using a DME arc, right? Just give me a second. Now, there is one more thing I wanted to talk about. Uh, how to, like, once, let's suppose you have intercepted, right? You are on a 20 mile DME arc, and now how to like keep maintaining that distance. It'll be much more easily explained once I'm showing you in the simulator how it is done. But there are two methods to it. Uh, my Let's just put it in for now. Uh, Methods for an arc, right? Now, one is twist and turn right? Method. The other method is using RMI. So that basically means radio magnetic indication. Yeah, it is indication needle. Yeah, so there it is. So one is to turn and twist. So turn and twist is nothing. It is just uh, turning your heading bug 10 degrees to the left or right in whichever direction you're supposed to go, and slowly turning towards it. And every time you intercept the heading, you again twist it a little, thereby like maintaining a constant distance. I used to perform the RMI method because it's much more easier, and I would suggest you also to do that, and it's much more accurate to perform. And before I move ahead into the cockpit, I just wanted to talk once, let's say you are, uh, same thing, just a second. Let's just suppose you have taken off. This is the DME arc. You're, you are over, you're over here now, right? Let's just remove this. Now, of course, you're gonna, you are going to turn left, right? Now, question arises, how early should you turn left, right? You don't want to undershoot the path, or you don't want to overshoot the path, all right? You just want to be like, it's not a perfect method, but it does the work. So like if any examiner asks you, like how far from the arc are you supposed to start turning, right? Uh, my instructors told me the simple method, just take 1% of your ground speed, right? Now, suppose not your indicated, but your ground speed, because winds are a factor. Now, let's suppose you're flying at 90 knots of ground speed, right? So you take 10%, sorry, 1%, divide it, you get 0.9. So in order to intercept on 20 DME, you should start turning left at 19.1 DME, because you don't want to, like, basically we are flying IFR flight plan, right? So we are presuming that it's a IMC situation, and as you know, in IMC situation you are not supposed to bank more than let's say it should be nothing more than a rate 1 turn. So keeping in mind that you will always have to use a rate 1 turn, you should always use this method. 1% of the ground speed, that'll in this case 90 knots, will give you 0.9. You start turning left at around 19.1 DME, and hopefully you would be successful to join the 20 DME arc using a rate 1 turn. So yeah, in theory, That's pretty much it. And now let's move to the fun part. Let's actually see how a DME arc or a GPS arc is done in practice. All right, see you there. On theory, actually. So we can start moving. As you can see, we are currently holding short of runway 09er left at Sanford base. And as we discussed, I'll just show you on the chart. If you could just give me a second, Navigraph. Let me open the IFR charts first, please. There I am. Let me zoom in. There I am. So there's the chart. As you can see, we are located on the Sanford Air Base, and we are currently holding short of runway 09er, right? And my plan is just to repeat whatever we learned in theory. So we're gonna track Orlando VOR, okay? And we're gonna go north and then track it down on a 20 DME and come here and join Mambo. And I'm just gonna make sure we hit Mambo because that only proves that we were able to maintain a 20 DME. And of course, we can see it on our nav display as well. Now, just a couple of things before we take off. I am going to use autopilot during our cruise. Uh, Not because that it has to be flown with an autopilot. It will be like most of the times for all the students, it will be flown manually because no instructor would allow that. So you will have to fly it manually, but I'll be using autopilot because it's hard for me to sit on this sim and not have the controls in my hand, and I have to press buttons, change frequency and everything, change altitude. It's a little difficult, so that's why I'll be using the autopilot, but the basics will remain the same. All right, so let's get going. So always before departing, make sure your display is set up, right? So in this case, our first requirement will be we need to set up the the VOR frequency. So in this case, the VOR frequency for Orlando VORTAC is 112.2, all right? So we're gonna put it in the nav1. So let's put it there, 112.2. 2.2, right? There you go. And there is all that's Oscar Romeo Lima. So it's identified. There's no need to, like, if you want to hear a tone, you can obviously do that. It's on, let's ID it just to be sure. And let's switch on nav1 so you can hear it. And like, it's not required. So that's pretty much it. And what should we do here? Now, there were two methods to it. I told you one is twist and turn, and one was RMI. I usually go for the RMI one because it's much more helpful to me. So what do we do here? So we go to CDI. The CDI will go to nav1. So that'll be VOR. You can see the VOR selected over here now. Now you go to your PFD output. You put in bearing 1. First of all, you should put in DME so you can see like what is the DME distance, because we want to track 20 DME, right? So that is there, and you put in bearing. Just a second. I'm sorry. Where is that? Am I missing something? Uh, 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 uh. Just a second, guys. Yes, bearing one. Yeah, so this is the RMI needle. It should come up. Maybe I'm wrong. Just let me figure this one out. If you can just give me a minute. It's a little different. DME is right there. Yeah, so this is pretty much it. And just for our ease, we're gonna set up our autopilot as well. We're gonna use a heading of 359, and altitude will be 3,000 feet, right? 3,000 feet. And we're gonna use a climb rate of, we're not gonna use climb rate, we're gonna use, right? So we are set up, and so let's begin. Parking brake off, mixture full lean. Let's go then. Set up. And there it is. And just as a clue, like it'll be easier. Like, all right, I'll tell you that later because that comes up for VOR holds, not for, I'm sorry, for, what do you say? Your, not for DME arcs. So let's go. Full power set. V1 and rotate. And positive climb, flaps up. Heading engaged, altitude engaged, and autopilot engaged. And sorry for that terrible takeoff. I was just trying to figure out. That's why I was saying I'm going to use autopilot just for the ease because I knew this was going to happen. And let's see from outside. Where's the landing lights? That's weird. The landing light is still not on. Okay, never mind. So we're going to continue a climb of around 1,000 feet per minute. And in the meantime, I would like you to observe. So here's the thing. You can see that we are currently, if I turn my OBS to, so we are currently on radial, you can say 020, right? and we are still climbing towards, and you can see the distance right now is around 17.8 nautical mile, right? Now, I want you to get the ground speed once we have leveled out, of course. And and as you can see, this small needle over here, this is the RMI. Now, what do you have to do? Of course, we're going to turn left to intercept the what do you say the DMA arc. I want you to keep this needle just on the west, right, exactly perpendicular to us. All right. If it moves down, you have to move closer. If it moves up, you have to move further away. Right. If you keep maintaining it on like westerly heading, you'll easily be able to what do you say intercept the and maintain, sorry, the 20 DME. Here it is, 19.1 ground speed, 97. So let's say, give or take, we should start turning now. Where's the heading bug? Sure, slowly start turning. Slowly start turning. And there's our altitude. Reduce the speed so we can maintain 23 right around. So we are currently on 20 DME. So keep turning, keep turning, keep turning till the time what do you say, the RMI is on the directly perpendicular to us. Like currently it's on south, it should stay on south, right? And we are established on a DME radial. And we are 20 DME as of now. Now, as you see, we are 20.2. So in that case, I would like to move a little towards the left. So you turn a little towards the left, right? And you try to move a little closer, thereby making the needle move a little towards up, and we keep maintaining it. Let's reduce the power a little more. At that point, what I was trying to tell you was that yeah, so I was trying to tell you that how do we know, like, suppose now we have GPS and everything, but let's just say that if we did not have GPS, right? Just a second, we are 19.6, we're moving in closer, so we want to go a little right. Let's move a little right. I'm sorry for just. Little towards right. Yeah, there it is. So yeah, I was saying that now, of course, we do have what do you say, GPS, so we know where Mambo is. But in actual IFR flying, if we are just supposed to do a VOR, how do you know that you've intercepted the actual point? So the key to that is, if I can just open my chart, just a second. Yeah, there it is. And in the meantime, we'll also keep a look at our, what do you say, our RMI. So we again recapture the 20 DME. So yeah, so I was asking, like, if suppose we did not have let's say we did not have GPS, how would we know that are we really intercepting Mambo or not? So the answer to that is, what do? You know that it's on a radial of 129. If you can see closely, I'm sorry. Just a second, guys. Yeah, here it is. You can see that it's on a radial of 129, right? So what do? You dial in 129. Set a course of 129. There you go. Yeah. So, so the trick to that is the moment this bar meets the center and your 20 DME out, there it is, voila, you're on Mambo. That's what I was trying to talk about. Uh, this is a method which is usually used like in the older days, but just in case if you have a RAM failure, you do not have some kind of GPS or a handheld GPS or something like that. This is how you track. Uh, this is how you track VOR and certain points on the radials. And there you go. We are about to intercept. So at 19.9 DME, so we again try to move the RMI right perpendicular to us. Just a little more. Again, we turn a little towards the left. A little towards the left more. There you go. It's right at perpendicular, and hopefully we'll now be able to maintain, what do you say, the distance. So that's pretty much it. That's how you fly basically a DME arc. Now, if we keep flying this arc, you can see on my navigational display. If I can I zoom it out? Yep, I can. So if we keep following this point, I'm not able to spot Mambo actually. You know what? Just for like the ease, let's put it in as well on our GPS. There you go. So there is M. A. And there's a point. There you go. Mambo. So now, okay, the point has moved slightly below the RMI. So we need to again bring it a little closer towards our perpendicular. So in that case, again, let's move a little left, right? And on our nav display, you can see we are inching close on this arc towards Mambo, right? So let's keep at it for now. And we know that Mambo is like, according to the chart, it's located at 20 DME on 129 radial of ORL. So when we are 20 DME at 129 radial of Orlando executive, we should have intercepted the radial as well. So let's see. We are currently 7 miles out. And again, slowly we have to turn a little more towards the left because we are 20 DME and the RMI has again moved. We have to keep it right at perpendicular towards our left. And always remember, you have to keep adjusting so you do not lose the 20 DME arc. If I remember correctly, I think according to the ACS, that is the guide which suggests how a check is to be conducted. I think the limit on which you can maintain, on which you can lose the DME arc is plus minus 1 nautical mile. So make sure, like on a 20 nautical mile DME, if you go below 19 DME or you go above 21 DME, you fail the check. So make sure you're always within those limits. But with this RMI trick, I'll be surprised that if you go beyond 1.2 nautical miles also. This has always worked for me. And you can clearly see we are 3 miles out. We are about to intercept MOBO. And as you can see, the VOR is also alive now. It's slowly, the VOR needle, HSI needle is slowly moving towards us. And slowly moving towards us. And guys, I forgot to tell you during the theory part, on certain DME arcs, if you check out the IFR charts, there's a prescribed flight level as well. So on the KDAB, the Daytona 07 ILS approach, you had to fly that DME arc on 1600 feet. It's written right above where it was written 16.9 nautical miles from Ormond VOR. So that is the place where you're supposed to, like at that altitude, you're supposed to fly. And sometimes some arcs also have a prescribed speed also, but that's mostly for the jetliners. Yeah, because of course we cannot fly very fast. So guys, there it is. We have intercepted MOBO, and that's our. We have completely intercepted the needle 129 at 20 nautical miles, and voila, we are right above MOBO. So that's pretty much how you fly, what do you say, a navigational arc. The same principle applies for every DME arc. It's GPS navigation or it's VOR navigation. So that's pretty much it. And I hope this lesson has been educational to you. If you like the video, I would love if you could subscribe. Gives me further motivation to keep producing my videos and help you fly the Cessna. Alright, take care guys, bye bye.